Okay, we will go through the exemplar problems in the class 11 physics chapter 8 gravitation. Okay, before going through I will show you the some parameters in the earth. This is earth. Okay, so here this is the equator. Okay, this is the equator, and this is the latitude varies from 0 at the equator and goes increasing till the north pole. Okay, so the latitude increases in this direction. This is north pole, and this is down is the south pole. Okay, so now in this what is equatorial plane and what is orbital plane? Equatorial plane is nothing but this equator, along this equator. So okay, this is equator, and the equatorial plane is in the same plane as the equator, but orbital plane varies based on the which direction satellite is revolving. Say for example, geostationary satellite, they revolve above the equator. Okay, for geostationary satellite, the equatorial plane and the orbital plane are same because they move around above the equator. So but for the polar satellite, they revolve between north and south poles in this. So the orbital plane for the polar satellite is above this, between the pole north pole and south pole. North south direction is the orbital plane for the polar satellite. East west direction is the orbital plane for the geostationary satellite. Okay. Okay, now there is a gravitational force between two masses, let us say m1 and m2. The force between these two masses, force equal to g into m1 m2 by r square, distance between these two masses. So okay, so g is the gravitational constant. The sum of the masses of the sum of the planets are given here. See, the sun has the highest mass, 10 power 30 range, earth 10 power 24 range, mercury 10 power 23, moon 10 power 23 range. Okay, see, this gravitational force is this acceleration due to gravity, g equal to g m mass of the earth divided by the earth radius. Okay, the acceleration due to gravity is independent of the mass of the object. That is important thing here. It is depends only on the mass of the earth. Okay, that is important. Independent of the mass of the earth, it depends on the mass of the independent mass of the object depends on the mass of the earth. So this is the escape velocity 2gre. Okay, so if you want some object to leave the earth's gravity, you have to launch with this escape velocity, then only it will escape from earth's gravity. So rocket to follow this formula. So now the earth revolves around the sun in the elliptical orbit. Okay, the ellipse have two forces. Okay, F1 and F2. One of them is sun. Okay, one of the forces sun will occupy. So now at any point on this ellipse orbit, if you add up these two distance from focus force 1 and distance, they are constant. Okay, like r1 plus r2 is same as r3 plus r4 at this point. Similarly for all the points, these two distances will be constant. This is the gravitational potential at any point due to mass m. Okay, this is the gravitational potential energy. Okay, G m1 m2 by r. This potential gravitational potential energy between the two masses. Gravitational potential is because of this mass, one single mass. Okay. Earth is an approximate sphere. If the interior contained matter which is not of the same density everywhere, that is important, same density is not there everywhere, then on the surface of the earth the acceleration due to gravity g will be different at different points. Okay, cannot be zero at any point, will be directed towards the center but not same everywhere. Okay, density is different means it will not be directed towards the center. Okay, only if the density same everywhere, then it will be directed towards the center due to gravity. Will have the same value everywhere. No, that is wrong, because different density will be same everywhere in magnet. Okay, it is not same everywhere. Okay, you can go through this law. As observed from the earth, sun appears to move in an approximate circular orbit. Okay, for the motion of the another planet like Mercury as observed from there, this would be okay. See, the earth revolves around sun due to the gravitational force. Okay, that gravitational force between the earth and Mercury is very less. Okay, you can see the mass of the planet, sun has the highest mass. Okay, so due to the gravity only one planet revolves around the earth or other planet. Okay, one planet, due to that gravity, the gravity between the earth and Mercury is very less. This is not true, because the major gravitational force on Mercury is due to the sun only. Okay, all the planets moving around the sun because of the more gravitational force. Mercury revolves around the sun. It is not not around the earth. It is not revolving around the earth. Gravitational force between the earth and Mercury is very less. Different points of the earth are slightly different distances from the sun, and hence experience different force due to gravitation. For a rigid body, we know that if the various forces act on various points on it, the resultant motion is as the net force act on the center of the mass. Okay, causing translation and net torque at the CM, causing the rotation around the axis of the center of mass. For the Earth Sun system, approximating the Earth as a uniform density sphere. So this is important, uniform density. The torque is zero, because torque is position vector, cross product of the force and the position vector. So both are in the same direction in this case. Okay, so r cross f, rf sin theta, theta is 0, that means the torque is 0. Cross product of two vectors is this, r cross f is rf sin theta, theta is 0, sin 0 0, so the torque is 0. Satellites orbiting around Earth have a finite life, and sometimes debris of the satellites fall on them. This is because the viscous force causing the speed of the satellite, and hence the height to gradually decrease. Due to this viscous force, the speed of the satellite and the height is gradually decrease. Both Earth and Moon are subject to gravitational force of the Sun. Both Earth and Moon, as observed from the Sun, the orbit of the Moon will not be strictly elliptical because the total gravitational force is not central. Not central means they are not aligned in the same direction between the centers. Example, force between the sun and moon and the earth and moon are not are in the different lines. Between the earth and moon is in a different direction. Sun and moon are different direction. Okay, they are not in central. They are not aligned properly in the same way, not always on the same line. It will differ based on the timing. Okay, this is not elliptical as observed from the sun. Not orbit is not elliptical because the moon is orbiting around the earth only. It is not elliptical but necessarily be a close deviates considerably from being the elliptical. Will not be directly elliptical because the total gravitational force on it is not central. That is it. In our solar system, the interplanetary region has a chunks of matter much smaller in size compared to the planets called asteroids. What is asteroids? In the solar system, the interplanetary region has a chunks of matter, that is asteroids. They will move in orbits like planets and obey Kepler's law. Okay, the asteroids also obey Kepler's law. Okay, the other things are not correct. Choose the wrong option. The inertial mass is a measure of the difficulty in accelerating a body by an external force, whereas the gravitation is relevant to determine the gravitational force on it by the external mass. Okay, the gravitational mass and inertial mass are equal in an experimental results. Okay, that is also correct. That the acceleration due to gravity on the earth is same for all bodies. Acceleration due to gravity is same for all bodies. Okay, is due to the bodies is due to the equality of the gravitational mass and the inertial mass. Okay, gravitational mass, inertial mass same in the experimental result. Gravitational mass of the particle like photon can depend on the presence of the neighboring heavy object. No, this is wrong. Okay, choose the wrong option. This is wrong. It not depends on the neighboring heavy object. But the inertial, okay, that this statement is wrong. Okay, particles of mass 2m, m and m are respectively at the point ABC. The AB is half of the distance of the BC. M is much smaller than m at t equal to 0 at subsequent times before any collision takes place. M will move towards 2m. Okay, you have to compute forces between these two and these two. Okay, here AB is the half the distance of BC. Okay, force between these two, AB equal to G mass of this 2m and mass of this m, then distance between this AB square. Similarly, this force, mass and this mass distance. Okay, now we have to use this relation. Okay, so AB equal to half BC. Then if you substitute, then it is this force is 8 times of this force, because this force is much more than the force between these two. Okay, then because this is greater than this, then m will move towards A, point A, that is towards this mass. Okay, Question number 9. Which of the following options are correct? Acceleration due to gravity decreases with increasing the altitude. Okay. When we go above the earth, the acceleration due to gravity decreases. Okay. Acceleration due to gravity increases with increase in depth. Okay. This is wrong. Increasing depth. When you go inside the earth, that is decreases. Acceleration due to gravity increases with increase in latitude. Okay. If you go along the latitude, the acceleration due to gravity increases and it will be more at the poles. Okay. Acceleration due to gravity independence of the mass of the earth. This is wrong. It is dependent on the mass of the earth. I already shown you. It is independent of the mass of the body, not independent on the mass of the earth. Okay. A is maximum at the poles and the minimum at the equator. Equator is minimum and it's increasing over the latitude and maximum at the poles. If the law of gravitation, instead of facing the inverse square, that is m1 m2 by r square, becomes inverse cube, that is m1 m2 by r cube, then the planets will not have the elliptical orbit. Okay. Kepler's third law, that Kepler between the periods and the radius of the semi-major axis is given. Planets will not have the elliptical orbit, that is a relation t square is directly proportional to the r cube. Okay, the circular orbits planet is not possible. Projectile motion of the stone thrown by the ant in the surface of the earth is approximately parabolic. Okay. For presently, if they are inverse square relation, then the period t square is directly from r cube. T is the time period of the revolution radius of the semi-major axis. If this becomes this, then that formula this will become parabolic. Okay. So you have to read the Kepler's third law, how the period and the radius of the semi-major axis are related. If the mass of the sun were 10 times smaller and the gravitational constant g is 10 times larger, then magnitude walking on the here this important thing you have to mention is the acceleration due to gravity, that is independent of the sun. Okay, so it does not matter here. So g actually where is mass of the earth and the radius of the earth only. Okay, mass and radius. So that gravitational constant 10 times means then g will become 10 times. Gm by r square re. Walking on the ground would become more difficult because of the more weight. Weight equal to mg, g 10 times will increase means more weight, so it will be difficult to walk. Acceleration due to gravity and earth will not change. This is wrong. That is what this depends on the gravitational constant. So the gravitational constant they are increasing by 10 times. So this statement is wrong. Due to gravity will not change means wrong. It depends on the gravitational constant. Raindrops will fall because more gravity. Aeroplanes will have to travel because of the more gravity. They have to travel faster. See here, this is independent of the mass of the body, but it depends on the mass of the earth. It depends on the gravitational constant also. So when increase the gravitational constant, this will value become more. If the sun and the planets carry huge amounts of the opposite charges means so the electrostatic force between these charges will be active. But this electrostatic force and gravitational force both obey inverse square law. Okay, q1 q2 by r square, here also m1 m2 by r square, both obey inverse square law. All the three Kepler's law will be valid still. Okay, they are valid. The second law will not change, first law will still be valid. Okay, this is the law of orbits, the law of areas. The only third law, this is the wrong actually. It's not only, all the laws will be still valid. Okay, third law is the period is directly proportional to the r cube. Okay. This is the time period how it is computed, depend the relation. There has been suggestions that the value of the gravitational constants g becomes smaller when considered over very large time period, billions of years in the future. If that constant becomes smaller, then we will be going around the sun, but not strictly in the closed orbits. After sufficiently long time, we will leave the solar system. See, nothing will change is wrong. We will become better off. No, that is also wrong. Okay, it's because of this gravitational constant is used in the gravity computation, force computation, so things will change. Supposing Newton's law of gravitation, the gravitational force F1 between the two masses are the positions. Okay, position vectors given, force and v2, and these are the answer. The acceleration due to gravity is different for the different objects. It depends on the position here based on this formula. Only the third law will be become invalid. For n negative object lighter than water will sink in the water. Which of the following are true? A polar satellite goes around the Earth's pole. Okay, polar satellites moves from the north-south direction only. That is correct. A geostationary satellite goes around in the east-west direction. Geostationary goes around. Geostationary satellite goes around the Earth in the east-west direction. It is geostationary goes around the Earth in the here east-west, here west-east. See a little different between the this is the direction is very important. Okay, from west to east direction, not from the east to west. Here also north to south direction. That is important. A polar coordinate goes on the east. This is wrong. Okay. The center of mass of extended body of the surface of the earth and its center of gravity is close to each other for the object of the size. Okay, this is based on the experimental results. Okay, center of gravity same as center of mass when gravity is uniform across the object. Okay, so these for the smaller object these two are same, so it depends on the weight of the center of mass. Okay, so based on the experimental result, this is what is less than 100 meters, these two are same, center of mass and the center of earth. Molecules in the air atmosphere are attracted by the gravitational force of the earth. Explain why all of them do not fall into the earth just like apple palm. Maybe due to the this weight of the particle, lightweight particles on 17. Molecules experience vertically downwards. Okay, due to the gravity, just like the apple falling from the due to the thermal motion, which in random their velocity is not in the vertical direction. Okay, The downward force of the gravity causes the density of the air in the atmosphere close to the earth. The density of the air is more near the atmosphere, then density will be less when you go up. So the lighter particles may not reach the earth's surface. Give one example of the central force and non-central force. Central gravitational force is between the center of the earth and the center of the sun. So that is the central force, gravitational force of the point mass. Electrostatic force due to point charges. Non-central force, spin dependent nuclear forces, magnetic force between the two current carrying loop. They are not non-central. Draw the aerial velocity versus the graph for the Mars. So 19. Aerial velocity. Okay, the aerial velocity means velocity for the particular area. Okay, that is constant. This will be all applicable for the Earth also. This is based on the Kepler's second law. What is the direction of the aerial velocity of the Earth around the Sun? The aerial velocity of the Earth around the Sun. It is normal to the plane containing Earth and the Sun as aerial velocity. How is the gravitational force between the two point masses affected when they are dipped in water, keeping this separation? Okay, this is gravitational force is independent of the medium. That is important. G is independent of the medium. It remains same as the gravitational force is independent of the medium separating the masses. Is it possible for a body to have inertia but no weight? Yeah, that is possible. Example, satellite. The satellite doesn't have a weight but it has inertia. Satellite around the earth, no weight but there is a mass is there because the gravity is not there, there is no weight. G is 0, the weight is 0 for the satellite, but energy mass can never be 0, so these two can be different. 22. Yes, the body will always have the mass, but the gravitational force on it can be 0. For example, when kept in the center of the earth. Center of the earth, gravity is 0. Center of the earth means it is center of the earth means it's inside the earth center. Gravity is 0, not on the surface of the earth. We can shield a charge from electric field by putting inside the hollow conductor. Can we shield a body from the gravitational influence of the pattern? No, we cannot shield the gravitational force by putting inside the hollow sphere. No, that is important. 23. We cannot shield the gravitational force like electric force. And astronauts inside the small spaceship orbiting around the Earth cannot detect gravity. If the space station orbiting around the Earth is a large size means can it detect gravity? 24. Yes, if the size of the space is large enough for him to detect the variation in G. If G large sizes G varies means it can get detect. The gravitational force between the two hollow spherical shell of radius are the uniform density and a point mass is F. Okay, the gravitational force. So the nature of the F versus R, where R is the distance from the point of the center to the hollow spherical shell. Hollow spherical shell, that is important here. Uniform density. Hollow spherical shell. 25. See, up to this, the force is 0, then after that then force will slowly decreases. Okay, because this hollow spherical shell, inside this hollow spherical mass is 0, that is why that force will be 0. So this is a hollow spherical shell up to this radius inside this hollow, that is why mass is 0. So force will be 0 up to this point. But after R, then force will be there because mass is concentrated on this ring. So there will be a force. Then after that it will keep decreasing because of this will increase. R will increase. Out of aphelion and perihelion, where is the speed? It is near to the earth. Whichever point is near to the earth, 26. At perihelion, because the earth has to cover greater linear distance to keep the aerial velocity. This is second law of Kepler, based on the second law of Kepler. Law of areas. Okay, what is the angle between the equatorial plane and the orbital plane? As I already told you, the orbital plane depends on the orbit of the satellite. Polar satellite north south. So the equatorial plane is on the equator. So there will be 90-degree angle between the polar satellite and the um, equatorial plane. But for the geostationary satellite, the angle is 0 because they are above the equatorial plane only. Okay, so this is the polar satellite, this is the geostationary, so this is the equatorial plane. Polar satellite between the north and south, so between these two planes 90-degree, but geostationary satellite above the equatorial plane, so that is why the 0 in this. Mean solar day is the interval between the two successive noon when sun passes through the zenith point. Sidereal day is the time between the two successive. Okay, actually sidereal day is 23 hours and 56 minutes. Solar day is 24 hours, that is 4 minutes less than the solar day. Earth is moving as well as spinning. Okay, moving around the sun as well as spinning itself. So solar day is 24 hours, sidereal day 23 hours. Every day the earth advances the orbit approximately 1 degree, because it takes 1 year for the earth to move around the sun, so approximately 1 degree per day. Okay, so important thing is that it is 4 minutes, sidereal day is 4 minutes less than the solar day. Okay, two identical heavy spheres are separated by the distance 10 times in their radius. Okay, 10 times the radius. Will the object placed at the midpoint? Okay, so the midpoint force will be 0 at the center, unstable when you move, so you have to compute the force and see. Okay, unstable when you move at the center, there will be equal and opposite forces. Unstable when you move that object towards the any of the masses. So the nature of the graph for the satellite orbiting around the Earth. This is the kinetic energy. As the radius of the orbit increases, kinetic energy decreases. The potential energy will increase. This is the total energy. Kinetic energy, potential energy is in the opposite way. Shown are the several curves. Explained only the reasons which curves among them as possible trajectory produced by the projectile. 31. The trajectory of the particle under the gravitational force of the earth will be a conic section. Okay, this is important. Conic section for the motion outside the earth with the center of the earth as the focus. So based on this criterion only C meets the requirement. So this one conic section, okay, above the earth. An object with mass m is raised from the surface of the earth to the height of the radius. It is taken from the r to 2r. The surface of the earth is at the height r, actually radius r, the center of the earth. What is the gain in the potential energy? So the initial potential energy, because at the height r, that is, it is in the surface of the earth, from the center of the earth is height at r. Final potential is 2r. Okay, the difference in the potential energy is this much. Now if you use gravitational constant gm equal to gr square, then it will become half mgr. Half mgr, that is mgr by 2. Mass m placed at the distance v and h along the normal through the center. Since okay, this 33. Okay, you can go through the turns. A star like sun has several bodies moving around it at distances. So consider all of them are moving in the circular orbits. Let r be the distance of the body from the center of the star, that is sun. Let its linear velocity be the, okay. As the radius r of the increases, determine which of the above quantities increase. Okay, based on the radius of the orbit. So how these quantities will vary. 34. Potential energy will increase, okay, as the r increases, the velocity will decrease, angular velocity also will decrease, k decreases as the inversely kinetic energy is inversely proportional to the as r increases, k will decrease, energy will increase, okay, and the angular momentum increases because it directly proportional to the orbital radius. 6 point masses of mass m are the vertices of the regular. Calculate the, okay, that is okay, they are given here hexagon. You can go through the terms. A satellite is placed in the equatorial geostationary orbit, okay, equatorial above the geostationary orbit around the earth for the communication. Calculate the height of that geostationary satellite. Find out the minimum number of satellites that are needed to cover that entire earth. So okay, we need 3 satellites. This is the height of the geostationary satellite, and we need minimum 3 satellites to cover the entire Earth. Entire Earth. Earth orbit is an ellipse, approximately this eccentricity. Thus, the Earth's distance from the Sun and the speed it moves around it, Sun from day to day. Okay, this means that the length of the solar day is not constant throughout the year. Okay, that 24 hours is not constant throughout the year. They are saying. Assume that Earth is okay. Okay, you can go through this answer. Okay, the satellites of the ellipse orbit around the Earth. Okay, this also you can go through the answer. Okay, to transfer a circular orbit at the apogee, we have to boost the velocity. By this can be done suitably firing rockets from the satellite. Okay, the if you want to raise the height of the satellite, then you have to fire the motors in the satellite. Okay.